Hey, it's Corona time. How's it going, guys? I wanted to work through this problem with you just to not leave you in the dark. I asked you guys to try this problem out. And so, whether you got somewhere, whether you finished the whole thing, whether you didn't even know where to start, consider this me showing you, like the next day in class, really how you needed to tackle this problem. All right, so what we were told was that we had a trapezoid here. So TRAP, pun intended, trapezoid, with TR congruent to PA. So this isn't just a normal trapezoid. This ends up being an isosceles trapezoid, right? Because it has its two non-parallel sides being congruent. And then they said D, E, F, and G are the midpoints of the indicated sides. Now, what they wanted us to do was connect together those four midpoints and prove that this ends up being a rhombus. Now, you might go, hey, Mr. G, at the end of not this past video in 6.7, but in the other video, the one prior to that in 6.6, at the very end of the video, you said that if we connected together the midpoints of four sides of a quadrilateral, that it would make a parallelogram. And that is true. If you take just a general quadrilateral, nothing special about it, it is guaranteed to make, and I will throw in here, at least a parallelogram. Now, if the starting shape is not just a normal quadrilateral, but if it's something more than just a quadrilateral, in this case like an isosceles trapezoid, then again, the midpoints, when they're all connected together, is going to guarantee at least a parallelogram. And what's something more than a parallelogram? Oh, how about a rhombus? So if you connect together the midpoints of an isosceles trapezoid, then the resulting shape is a rhombus. And that's what we're going to prove here. Now, consider, if we want to prove this is a rhombus, what are we going to have to show is true by definition to make a rhombus? Well, by definition, a rhombus is a parallelogram, so it's got two sets of parallel sides with four congruent sides. But consider there was another shape that had those two criteria that also had 90-degree angles in it, and that would have been a square. So we want to prove this thing is just a rhombus, and it's not something more than just a rhombus like a square. So we're going to need some coordinates for these. So we need to figure out first, what are the midpoints of D, E, F, and G here? All right, so to find the midpoint, all we really had to do was we were finding the average of our two endpoints. So if we start with D here, T is one endpoint and R is the other endpoint. And so we want to find what is the average of the x coordinates and of the y coordinates. Okay? So the x coordinates are negative 2b and negative 2a. So if I added those together, and I found the average, and I divided it by 2 because there's two sides. Man, this thing's really being choppy here. Then really, since all three of these have a common factor of 2, then that 2 can divide both of the 2's up top, and in the end, we end up getting negative a, and either plus negative b, or I can say negative a minus b. So there's our x coordinate for D, negative a minus b. All right, so let me put that over here. So this is going to have an x coordinate of negative a minus b. Now, what is the y coordinate of D? Well, the y coordinate would be the average of 2c and 0. So if I take 2c plus 0, I'm going to get 2c, and if I take 2c and divide it by 2, because there were two y coordinates, then the 2's are going to cancel, and that would leave me with a y coordinate of c. So point D has coordinates of negative a minus b, comma, c. Now, point E up here. Let's see. Let me erase some stuff here first. Okay. Now notice that E is right on the y-axis here. And so if E is on the y-axis, then it has an x coordinate of 0. And we could also see that if we took the average of negative 2b and positive 2b. If I add those together, I'm going to get 0, and 0 divided by 2 is 0. So E has an x coordinate of 0. And then what is the y coordinate? Well, what is the average of this y-coordinate and this y-coordinate. If I add 2c and 2c, that's 4c. And 4c divided by 2 is 2c again. And hopefully that makes sense why it's also 2c. Because if you look at point R, point E, and point A, notice they all go up the same amount in the coordinate plane. So they should all have the same y-coordinate. We didn't really have to do any math here if we had just thought about it a little bit. So 0, 2c is point E. I'm going to jump down here, and we're going to do the easiest one of the whole bunch here. Point G, notice it is right at the intersection of the x-axis and the y-axis. So it's at the origin. It's 0, 0. Now, F is going to be just like D, except it is symmetrically over here on the other side. And instead of negative a minus b, we're going to get a x-coordinate of just a plus b. But the y-coordinate, notice F is going to go up the same amount as D over here, so they'll have matching y-coordinates. So that was C. Okay, so now we're saying ignore the trapezoid. Ignore T, R, A, and P, and we want to focus our attention on the coordinates for D, E, F, and G. Whew, okay. So now we want to find distances, and we want to find slopes, because that'll help us determine if the sides are congruent to each other, if all four sides are congruent to each other. And that'll help us establish with slopes if we have parallel sides. And the slopes are also going to tell us if we have perpendicular slopes. So here's what I'm going to set up first here. No, get rid of that. Is I'm going to have, all right, D was at negative a minus b, comma c, and then we're going to subtract away e. So this is like towards the very beginning of the chapter when we actually had coordinates to work with. We took all of our connecting points and we subtracted them. So e was at 0, 2c, f is at a plus b, comma c, and then we're going to take f and subtract away g, and that's going to be super easy because it's just 0, 0. And f was a plus b, comma c. Now, instead of doing g minus d, well, that's, why not? We'll do g minus d. You could do d minus g, and it really doesn't matter. If I did d minus g, then I'd just be subtracting 0, 0 again. But if I'm subtracting away some negative stuff in d, then that'll give me some positive values, which will make it a little bit nicer. Anyway. Okay, so now let's do these differences here. So negative a minus b minus 0. Well, I'm still at negative a minus b. C minus 2c. What's negative c? Not approximately c. Negative c. For e minus f, 0 minus a plus b. Well, really, I'm subtracting the a and the b. Okay, so I'm really distributing my minus sign there. There we go. So I've really got negative a minus b. 2c minus c is a positive c. All right, f minus g, a plus b minus 0, a plus b. And c minus 0, we're at c. And then 0 minus a negative a minus b. Again, the subtracting is going to affect both the negative a and the negative b. So this will come back around to be a positive a plus b. And then 0 minus c is going to give us negative c. So remember, these differences represent two things for us. These differences represent the a and the b of the Pythagorean theorem, which is kind of confusing because we have coordinates that deal with a's and b's. So we've got Pythagorean theorem values for us, but these also represent the run and rise, respectively, of our slopes. All right, so let me clear those off here, and then let's get some room here. Let me push all of this up so that we can just focus on our points here. Okay, so now, if I wanted to find the distance between points D and E, we were using the Pythagorean theorem. And so this already represents kind of our big square root once we square root both sides of the Pythagorean theorem. We can do negative a minus b, that's a quantity we would have to square, plus negative c, quantity squared. And remember, we can't chop off all of these negatives because we're also going to use them with slopes, and slopes are allowed to be negative. Now, just keep in mind, whenever I square a negative number, when I take a negative times a negative, it's going to turn positive. So we're not going to end up with negative lengths, even if we keep the negatives in our Pythagorean theorem. So I'm going to leave this just like this for now, okay? Because then you'll see what's going to happen here. So the length from E to F, big square root, and then again, negative a minus b quantity squared plus c squared. The distance from F to G, big square root, quantity a plus b. I swear my hands aren't shaking. I'll swear plus c squared. And then the distance from, what are we at? G to D, square root, quantity a plus b squared. Maybe my hands are shaking because I have the coronavirus. Oh my god. Okay. Now, notice, I don't have the coronavirus, I promise. At least I don't think so. Oh my god. That all of these really are going to end up being the same value. Because remember, even if these are negatives, both of them are negatives, when we square them, they're going to both turn into positives. And these are already positive, so they're going to stay positive when I square them. And all of these other pieces, even though I have some positive, some negative, when I square them, they're all going to be positive. So this is showing me right here that all four of these, oh here, let me do it on the other side. Do it in yellow. There we go. That all four sides are congruent. Perfect. Now, let's start looking at the slopes. So the slope from D to E, remember, it's run is the first number that we have here, and then rise. So rise over run for slope, we'd have negative c over negative a minus b, and we'll simplify that soon. The slope from E to F would be c over negative a minus b. The slope from F to G would be c over a plus b. And the slope from G to D would be negative c over a plus b. Now, the only slope that I think is worthy of simplifying would be this very first one, because notice all three of these terms have negatives in them, which means if everything's negative up top and everything's negative down in the denominator, then in the end all the negatives will deserve to cancel. So in the end, I'm just going to do this. I'm going to cross out all the negatives because they'll all cancel each other out. And then here's the next thing we can notice. Remember, if it's a rhombus, by definition, it's got to be a parallelogram. So here's one slope, skip a slope, and then here is its opposite side, which notice is the same exact value. So those two sides are parallel to each other. And then the second slope, and then skip a side, go to the fourth slope. Those are going to be opposite sides of each other. And initially you might go, I don't think those are the same. But if you notice that the denominator of this second slope is all negative and the numerator is positive, versus in the fourth slope, the numerator is negative and all of the denominator is positive. What that tells me is one of the sides of my fraction, the numerator or the denominator, is negative. And so it's kind of like saying this. If I had negative 1 over 2 versus 1 over negative 2, that those are really equivalent values. So in the end, positive c over negative a minus b and negative c over positive a plus b are really equivalent values. And so they are parallel. So we have two sets of parallel sides with four congruent sides altogether. But remember, there's one other shape that this thing could be other than a rhombus, and that is a square. And so squares would have perpendicular, adjacent slopes. So all I got to do is look at two slopes that are right next to each other, like the first two. And so I've got c over a plus b versus c over negative a minus b. Are these two slopes opposite reciprocals of each other? And one of them is being met. The opposite idea is, because this whole slope is positive and this whole slope is negative overall, but notice these are not reciprocals of each other, right? The reciprocal means that the fraction would have to be flipped upside down in one versus the other. So these are showing me that they are not perpendicular, which means we have no 90-degree angle. And now I know this thing truly is not a square, because squares have to have 4 90-degree angles, and all I really need to do to disprove a square is just show that one of the angles is not going to be a right angle. And what angle is that specifically? Well, what is the common letter between DE and EF? Well, when side DE meets up with side EF, they meet up at angle E. So specifically, angle E is not a 90-degree angle. Okay, are we ready to finish this thing? So here's what I'm going to do. Let me clear off this top space up here. And we are going to finally conclude that this shape had to be a rhombus. So DEFG is a rhombus because, and then we're just going to focus on what the definition was, because it has 2 sets of parallel sides. So again, if you look at the official definition of a rhombus, it says it is a parallelogram. But what is a parallelogram? It has 2 sets of parallel sides. And all 4 sides are congruent. And we have the math right here to support that. But no right angles. So remember, that is disproving that it could be something more than a rhombus, like a square. All right, so there is our proof, complete with work, for why DEFG must be a rhombus. All right, you guys stay safe out there, and then we are going to start the next chapter tomorrow, or maybe today, depending on when you're watching this. So yeah, stay safe out there. Good luck. Get some exercise. Go run your mile in PE, or I don't know, maybe I'll see you guys running around town. I've been running a little bit myself. But stay healthy, avoid the corona, and we'll see you on the other side.